Example 1, we're supposed to add the two polynomials, write the answer in descending order of the variable. And let me just say this, whether it says plus or minus, they're going to say add every time in this book. Algebraic addition, add if the signs are the same, subtract if the signs are different. So that's what that's about. So every time you're going to see add, even if it says minus, okay, you add or subtract based on what you're looking at. Now what you're noticing here is we have x cubed plus 3x squared plus 2, the first polynomial, being added to 2x cubed plus 4, the second polynomial. We got parentheses around both polynomials. Those are there for effect only. They're not doing anything. In general, anytime you look at a polynomial that has parentheses, there's officially a number in front. In this case, it's a positive 1. In this case, it's a positive 1. And what you do to get the parentheses to go away is you multiply that positive 1 through. Multiplying by positive 1 doesn't change anything. So the end result of this polynomial is going to be x cubed plus 3x squared, then plus 2. Notice how I wrote it on my board here. X cubed plus 3x squared, left a gap, plus 2. Why do you think I left a gap?
Because you have to add 2.
Look at the powers of x. What's missing?
2x.
I got x to the third, then I got x to the second.
2x.
I got x to the first is missing, right? And then 2. So when you look at a polynomial, consider the order of letters, specifically descending order of the variable. What that means is they want the highest power first, next highest power, and so on. They want you to account for missing powers. So whatever the highest power is, in this case 3, every power has to be accounted for. So third power, second power, first power, constant. All right? So since there's no x to the first power, I'm just leaving a gap there in case there's an x to the first power in the second one. For the second one, I'm going to line up like terms. So instead of writing this over here, I'm going to line up stuff. I'm going to put columns here. So 1 times 2x cubed makes plus 2x cubed. And then 1 times 4 is going to be plus 4. How many x cubes is this blue one?
3.
This blue one?
1.
That's just 1, right? 1x cubed. So looking at what I've got written on my paper, 1x cubed is being added to 2x cubed, 3x squared is being added to nothing because there's no other x squared terms, 2 and 4 are being added together because they're both constants. And again, I want descending order of the variable, so I want to get to my highest power first, then my next highest power all the way down to the constant, which is no power of x. 1x plus 2x cubed, these two things make 3x cubed. 3x squared plus nothing makes 3x squared. 2 plus 4 makes plus 6, and since x never showed up, I'm just going to go ahead and stick them together again, not leaving that gap. Okay, sometimes those gaps get filled, sometimes they don't. If they do, fine. If not, then just squish it all back together into a nice expression. I know I'm done because the powers don't match. Cubed, squared, constant. Okay, can't add or subtract different powers. Again, when I'm adding up powers, I don't change the powers. These match so they can be added. 1 and 2 make a new number 3, but x cubed stays the same. 3x squared is all that is. 2 and 4 makes 6. Everything's positive because everything's positive. I added everything because they're all the same sign.